Mazda's CEO just made a statement that sent shockwaves through the automotive industry. Their new Rotary engine will destroy the electric vehicle industry. This bold declaration comes at a critical time when EVs face mounting challenges with battery costs consuming 40% of vehicle prices and widespread charging infrastructure gaps. The timing isn't coincidental. While Tesla and BYD struggle with range anxiety and charging limitations, Mazda's compact rotary engine promises to deliver superior performance at lower costs without battery dependence. But there's a strategic shift happening that most analysts are missing, and it could fundamentally alter the $500 billion race toward automotive electrification. We'll analyze exactly how this technology works, why it threatens EV dominance, and whether Mazda's engineering breakthrough can actually challenge Tesla's market position. Let's dive right in. Mazda's latest rotary engine represents a fundamental departure from both traditional internal combustion and electric powertrains. Unlike conventional piston engines that rely on up and down motion, this compact power plant uses a triangular rotor spinning within an oval chamber. Imagine a three-sided gear rolling smoothly inside a racetrack, generating power through continuous rotation rather than explosive jolts. The engineering breakthrough lies in how Mazda solved the rotary's historical weakness: catastrophic fuel consumption. Previous rotary engines from the legendary RX-7 consumed nearly double the fuel of equivalent piston engines, earning a reputation as gas guzzlers. Mazda's new design integrates high-efficiency fuel injection technology and advanced cooling systems that extract maximum energy from every drop of fuel, achieving what engineers previously thought impossible. Here's what makes this particularly impressive. The entire engine assembly weighs roughly 60% less than a comparable piston engine while delivering identical power output. Where a traditional four-cylinder engine weighs 300 pounds, Mazda's rotary achieves the same performance at just 180 pounds. This dramatic weight reduction alone improves vehicle dynamics and fuel economy by 15 to 20%. And here's what few people realize. Mazda positioned this engine not as an EV competitor, but as a hybrid range extender. The rotary doesn't power the wheels directly. Instead, it charges the battery seamlessly when needed, eliminating the range anxiety that affects 73% of potential EV buyers. This hybrid approach allows for a much smaller, cheaper battery pack, while providing unlimited range through existing fuel infrastructure. Testing data from Mazda's MX-30, equipped with rotary range extension, shows over 400 miles of total range, matching gasoline cars while maintaining electric smoothness during city driving. The rotary activates transparently when battery levels drop, providing what engineers call invisible range extension. Most drivers never notice the transition, but this engineering elegance masks a deeper strategic calculation. We'll come back to this point later, but Mazda's true target isn't Tesla's technology. It's Tesla's fundamental business model assumptions. But this is just the beginning. What's really surprising is how this technology exposes critical vulnerabilities in the entire EV industry. Tesla's empire rests on three supposedly unshakable pillars: superior battery technology, extensive charging infrastructure, and integrated software. Mazda's rotary hybrid doesn't compete with these advantages. It makes them irrelevant. While Tesla spent $7 billion building 50,000 supercharger stations globally, Mazda's customers access 150,000 gas stations in America alone, refueling in under 5 minutes instead of 30 to 45 minutes for fast charging. The timing reveals a strategic masterstroke. EV manufacturers face mounting pressure from battery costs, consuming 40 to 45% of total vehicle price. A Tesla Model 3 battery replacement costs $15,000, while Mazda's entire rotary engine rebuilds for under $3,000. As first-generation EVs approach battery replacement age, this cost differential becomes a consumer nightmare. But there's a detail most analysts overlook. Charging infrastructure remains fundamentally broken outside major metropolitan areas. Despite $7.5 billion in federal charging investments, rural America has one public charger per 100 square miles. This geographic divide creates a two-tier transportation system: EVs for urban elites, gasoline for everyone else. What happens when other manufacturers recognize this opportunity? Toyota, already skeptical of pure EV strategies, publicly supports multiple powertrain technologies. Honda maintains robust hybrid development despite recent EV commitments. Both companies hold rotary engine patents and could rapidly deploy competing systems within 24 months. And here's what's truly noteworthy. Regulatory loopholes favor Mazda's approach. While California mandates EV sales quotas, rotary hybrid systems qualify as zero-emission vehicles during electric-only operation. Manufacturers can meet environmental mandates without full electrification, a regulatory arbitrage worth billions. The competitive response reveals industry anxiety. Tesla hasn't directly addressed Mazda's claims, instead announcing vague promises about battery cost reduction. BYD continues aggressive expansion, but faces identical infrastructure limitations. European manufacturers find themselves trapped. Billions committed to EV platforms, but charging networks varying dramatically between Germany's comprehensive coverage and Eastern Europe's sparse infrastructure. Consumer behavior data exposes the real threat. 73% of potential EV buyers cite range anxiety as their primary concern, even those with home charging access. If Mazda proves rotary hybrids eliminate this anxiety while maintaining environmental benefits, it fundamentally alters the purchase equation for millions of consumers. This leads to a remarkable discovery about market psychology. EV adoption isn't primarily driven by environmental concern. Surveys consistently show convenience and cost as top factors. And here's why this changes everything. The entire EV transition assumes consumers will accept current limitations for future benefits. Mazda offers immediate solutions to persistent problems, potentially derailing a decade of industry transformation. The next 5 years will determine whether Mazda triggered a genuine revolution or merely delayed the inevitable electric future. Current trajectories suggest both scenarios remain possible, with consumer behavior as the ultimate deciding factor. Mazda faces formidable scaling challenges. Their current production capacity handles roughly 10,000 rotary engines annually compared to Tesla's 1.8 million vehicle output. Scaling requires massive investment and 3 to 5 years minimum, potentially allowing EV manufacturers to address current weaknesses before rotary hybrids achieve market impact. Why would traditional automakers risk billions developing competing rotary systems? The answer reveals sophisticated hedging strategies. Toyota's $13 billion hydrogen investment and continued hybrid development suggest major manufacturers prefer technological diversity over single-solution bets. If charging infrastructure stalls or battery prices plateau, alternative powertrains provide crucial flexibility. But there's uncertainty embedded in every projection. Battery technology advances rapidly. Solid-state batteries promise 10-minute charging and million-mile lifespans by 2030. Charging infrastructure deployment accelerates through government mandates and private investment. Tesla's network expansion could address rural limitations within this decade. The environmental calculation adds complexity that few discuss honestly. While rotary hybrids reduce emissions compared to conventional vehicles, they can't achieve zero operational emissions like pure EVs. As electricity grids transition to renewable sources, now 30% of U.S. generation, this distinction becomes increasingly important for climate-conscious consumers. And here's what industry insiders know, but rarely acknowledge. Government ICE bans between 2030 to 2040 include hybrid exceptions in most jurisdictions. Norway, leading global EV adoption at 89% market share, still permits hybrid sales indefinitely. This regulatory nuance could extend rotary hybrid viability well beyond initial projections. The economic implications extend far beyond vehicle sales. EV manufacturers have committed $100 billion to battery supply chains, from lithium mining to gigafactory construction. Significant rotary hybrid adoption could strand these investments while revitalizing traditional automotive supply chains and small engine manufacturing. But here's the most intriguing possibility. Consumers might reject the forced choice entirely. Instead of EV versus ICE, multiple viable alternatives could coexist based on individual needs and preferences. Urban commuters might choose pure EVs for efficiency and convenience. Rural drivers could prefer rotary hybrids for range and infrastructure access. Commercial fleets might adopt hydrogen for heavy-duty applications. The ultimate victor in this technological battle may be market diversity itself, forcing manufacturers to compete on actual consumer value rather than regulatory compliance or environmental virtue signaling. Whether Mazda's rotary revolution derails the EV transition or creates healthy competition, one conclusion seems certain. The automotive transformation has become far more complex, competitive, and consumer-focused than anyone anticipated. And for car buyers worldwide, that complexity translates into better options, lower prices, and technologies actually designed around human needs rather than industry assumptions. The revolution isn't just beginning, it's accelerating in directions no one predicted. This is exactly why Mazda's bold statement isn't just automotive industry posturing. It's a direct challenge to the fundamental assumption that electric vehicles represent the only path forward. What this means is that consumers may not have to choose between environmental responsibility and practical convenience after all. The bigger picture reveals something remarkable. We're witnessing the emergence of true technological diversity in transportation. Just as the space industry evolved from government monopolies to private innovation creating multiple pathways to orbit, the automotive sector is fracturing the EV or nothing narrative. Mazda's rotary hybrid approach represents what happens when engineering solves real problems instead of following industry groupthink. And this is just the beginning. Toyota's hydrogen investments, BMW's synthetic fuel research, and startup companies developing everything from compressed air engines to alcohol-powered hybrids suggest we're entering an era of transportation innovation not seen since the early 1900s. The next 24 months will determine whether this becomes a genuine revolution or merely a footnote in EV dominance. Here's what's happening next. Major automakers must decide by 2025 whether to double down on pure electrification or hedge with alternative technologies. Consumer adoption patterns over the next 2 years will largely dictate these billion-dollar strategic decisions. How do you think this rotary resurgence will impact your next vehicle purchase? Will range anxiety and charging limitations drive you toward hybrid solutions? Or do you believe pure EVs will solve these problems fast enough to maintain momentum? This is Tech Revolution, and we dive deep into breakthrough technologies reshaping entire industries. If you want more analysis like this, that cuts through marketing hype to reveal what's really happening, hit subscribe. For the latest developments in automotive innovation and the technologies challenging conventional wisdom, you know where to find us. The future of transportation isn't electric or gasoline. It's choice, competition, and technologies designed around human needs rather than corporate assumptions.